Okay, so I just want to go over a few questions on the Algebra 1 Regents from last year, last June 2024. I particularly want to go over about 6 questions that have to do with using the store button as a quick way to solve questions on here. There's about 6 questions that you can do without really doing any math computations if you know how to use the store button in your TI-84. And these questions involve looking for something where it's saying equivalent to the equation is true, which solution is true, so that you're looking for an equivalent expression or something that kind of means the same thing. Okay, so let's take a look at number 3. Okay, so this is an equation where you're looking for which expressions are equivalent, right? Or there's an equal sign involved, so it wants to know which equation is true. Now, to solve this, rather than do a lot of math, which if you know how exponents work, that's great. You can go about that way using the rules of exponents, or you can decide to pick a value for x and use your calculator. So I'm going to pick a value for x here. I'm going to hit 1 store x. So now when I do that, I make all of my x's equal to 1. And now I'm going to just write in the equations and see which one gives me the same value on the left side of the equal sign and the right side of the equal sign. Okay, so which one makes the equation true? So we have x squared. I use the up arrow sign or caret sign. You can use the square button, right? But when you're going to use other exponents, you're going to have to use that up arrow sign. So, multiplied times x to the third, and that's going to give me 1. And when we do x to the 5th, we also get 1. So our correct answer is number 1. So x squared times x cubed equals x to the 5th. They both, on both sides, it equals 1. Now I'm going to do number 2 here just to show you that, yeah, we got the answer right away, but if you would have tried the other ones, you would have saw that it didn't work. It wouldn't have worked out. So we'll do number 2. Now remember, I set x as 1, and it's going to stay 1. Okay, until I store a different value for x. So we have 3 to the x times 3 squared. Okay, and that gives me a value of 27. So when we do 9 to the 2x, we get 81. So 27 on one side of the equal sign and 81 on the other, they are not equal. Okay, so that was just a quick way you could use the store button. And I've showed in class that when you plug in a number, you're able to solve two different parts of the equations to see, two sides of the equations to see if the sides are equal or true. So let's try another one. Okay. All right, so this one, number 4. I don't know if you could have moved this over and show you number 4. So this is a nice polynomial expression, and there's a couple things going on in it, right? We have a negative sign in front, then we're adding the polynomial. So there is a bit of math involved in this. Now, rather than go so intense with the computations, because it really, like when you're solving these things, even when you're really good at math, or like you really get polynomials, there's room for errors. Okay, so what I'm gonna do is, rather than go and do all of the math, I'm gonna use my calculator. And I already have x stored as 1, but I'll show you 1 store x again. Okay, and you could use a different number, but 1 is just the easiest number, I think, to work with. And now I'm going to take this whole equation and solve it where x equals 1. So I have negative 2 right, parentheses, let me move this in, -2 parentheses x squared minus 2x plus 1 parentheses plus 3x squared plus 3x minus 5. Okay, so now I'm just going to hit enter, and I see coincidentally that when we make x1, okay, that polynomial expression is equal to 1. So we have when x is 1, right, this expression equals 1. So now we want to find one other expression in our answers, right, in our choices that when x is 1, it also gives us 1. And that'll tell us that it's equal to that expression. Okay, so let's do another one. All right, I'm going to just start with 1 because it's the first one. And I'm going to write that into my calculator. X is already stored as 1. So x squared plus x minus 4. And we're looking for 1 for the answer. That's -2. That's not going to work. So it is not 1. Okay, so let's try the next one. X squared minus x minus 7. We're going to hit enter, and that's -7, so that can't be the answer. We're looking for one that gives us -1. So let's try x squared plus 7x minus 4. Okay, that gives us 4, so it can't be 3. We know that the answer is 4, and let's just check it so that I show you that it is true. Right, x squared plus 7x minus 7, and we are looking for 1, and that's our answer. We get 1. So we can say, right, that this expression, -2 parentheses x squared minus 2x plus 1 plus 3x squared plus 3x minus 5 equals, oh, I'm running out of space here. Let me see if I can move that over. Equals, right, x squared plus 7x minus 7. Okay, those expressions are equivalent. All right, let's take a look at another one. Okay, and we have number 9. And this one, right, we're going to use the store button for, right, it gives us values for 0. So let's take a look at number 9. The zeros of the function f of x equals x parentheses x minus 5 parentheses 3x plus 6 are. So, okay, we're looking for zeros, so of the function f of x. Now, saying f of x is just like if we were to say y equals x minus 5, right, times 3x plus 6, okay? But saying f of x is really a more mature way that we say functions. It's language, right? That's how mathematicians start to say functions as we get more in depth in math and as math becomes a little more complex. So now that we see that f of x is the same as saying y equals, okay, there's a couple of different ways we can do this, okay? Now, we can graph it. If you graph it, that's great if you know how to do it and find the zeros. So when we're looking for zeros, we're looking for when y equals 0. That's what it means. So when y equals 0, it's crossing the x-axis. Okay, so everywhere on the x-axis, y is at 0, okay, when it's crossing it. So everywhere here on the x-axis, over here, over here, over here, over here, those are all going to be y equals 0. so let's take a look at when we plug this into the calculator, okay? So the first thing I want you to do is I want you to go to y equals, and then I have it already set up here. So this is the equation, right? Again, I just put it in the calculator as I see it. The calculator knows how to do the work, okay? So now I'm going to hit graph. Okay, so I have a graph, and I see that it crosses the x-axis, axis 3 times, and that makes sense to me because over here I have 3 different monomials with x in it, and we know from our zero product property this x must be a 0 because if we multiply this, if it's 0 times any of these, we're going to get 0 and we're going to end up with a 0. Okay, so I mean, that's a little more advanced, but looking at this, knowing that there's 3 x's, which would make it also a 3-degree polynomial, there should be 3 zeros. At most, there can be 3 zeros. Okay, so now just looking at this graph, I see definitely that there is a 0 at the origin, and also that, you know, because there's 3 zeros, it can't be 3 and 4. It has to be 1 or 2. So, and looking at it, I can, because this graph is so easy to see, I can from there go, okay, well, it moves 2 to the left, so I'm going to say, right, it goes 2 to the left, so I have a -2, right? I have a 0 here, and then it also crosses the x-axis at 5. Okay, so that is this answer. Now, if we go to the table, we see we're looking for when y equals 0. We see when x is -2, y is 0. We see when x is 0, y is 0. And we also see when x is 5, y is 0. That is another way to do it. However, if you are like, I don't remember how to put it in, I don't remember how to find y equals, give me a second, I'm going to pull this calculator back up. I don't know where it went, but I will find it. There it is. Ooh, I've got a lot of things open there. Okay, so I'm going to set values for x and see if it works. See if I'm right here. So because I know the answer, I'm not going to try them all right now, but I'm going to show you you can plug in the values for x using the store function, and you'll be able to see if it's true. So we had 0 as x. So I'm going to store x as 0. Okay. Then I'm going to put in the expression function x parentheses x minus 5 parentheses 3x plus 6 parentheses. Now I'm going to hit enter. Okay, so I know when x is 0, right, it works, y equals 0. So we're looking for when x is a value, my outcome y is going to be 0. Okay, so I'm going to try it as x is 5. So I'm going to hit 5 store x. Okay, now my x is 5. Okay, so I'm going to actually go up and highlight this expression and hit enter. Okay, that's how you copy and paste the expression. And so after I hit enter, I already stored x is 5. I hit enter again. Okay, when x is 5, y is 0. So now I'm going to try it again with -2. -2 store x, enter. Okay, and notice I use the negative sign, not the minus sign. Okay, it's different in the calculator. It's calculator language. When you're starting an expression, you would use the negative sign. Okay, so now I'm going to go up again and highlight, okay, the expression I want and hit enter, copy and paste it, right? I have my x set, I hit enter, and it's 0. So when x is -2, y is 0. And if you were to try this, right, if I was to try any of the numbers from 1, and I'm just going to try this to show you, you can still do it, right? I'll do -5, store x, okay? And I'm going to highlight the expression, hit enter, and we see that negative 450 is not 0. So number 1 wouldn't have worked, right? And you could go straight to using the store button, and you could have tried 1 first and the values of x and saw, okay, that's not going to work, right? And then go to the next one. Okay,